Woo!
Woo!
You're back. It's the Micro Frontends Meetup. Hi, and welcome everyone to this episode in July of the Micro Frontends Meetup. I'm your host, Florian Rappel, but I'm not alone. With me is also our dearest friend, Florian Weininger.
Today, hosted by the two flows. It's a pleasure, everyone. Thank you so much for joining.
Yeah. Awesome. As usual, we have some ground rules, so let's briefly go over them before we get started. The first one is that this session is being recorded and afterwards being made available on YouTube. So the stream is also currently going out on YouTube and on LinkedIn. If you want to watch it later, the URL will be made available on the meetup.microfrontends.cloud website and, of course, through all the other means. So if you follow us on social media, you will find the URL also there. So if you don't want to be in the recording on stream, then just don't write anything and just watch it, and it's fine. Also, if you, and please do so, are engaging in the chat, then please follow the code of conduct. It's really not that difficult to follow, so just don't harass anyone or just stay within usual, let's say, human boundaries. So really try to be on topic, and but jokes and everything is, of course, also fine. Okay, just be gentle and polite, follow common sense. So far, we didn't have any strikes here or anyone who's, let's say, going out of bounds. So therefore, let's just keep it that way. And any activity, of course, in the chat room, much appreciated. Finally, before I make some announcements, if you want to be a guest on the show, so there will be now a monthly episode until the end of the year, just write me. Or you can also use the call for sessions on sessionize.com. Just submit your proposal there. And then we welcome you here in the show, and we can have an hour together where we talk about your solution and your experiences concerning Micro Frontends, of course. So just message me, just submit your proposal, and there we go. Just find me on LinkedIn or the URL at sessionize at micro-frontends-meetup. This is also on the meetup.microfrontends.cloud website linked. So every link I show will always be also linked from there. Finally, two announcements. As usual, we keep on doing these workshops for the Micro Frontends Cloud. There are how-to Micro Frontend workshops. Check out, I think there are just 2 more scheduled in this year, or is it one is already sold out and there's just the other one in September? I forgot what it is, but anyway, check it out if you're interested. I think the one in September is a Module Federation Essentials workshop. And of course, if you or your company wants to have custom tailored workshops, always get in touch. We do that as well, besides the publicly available ones. And speaking of workshops, so final thing now before we get started, on Monday and Tuesday, there is the workshop that was, let's say, planned and will be conducted in the area of the Micro Frontends conference that was just happening pretty much a month ago. So this is the Tooling Independent Micro Frontends with Module Federation. There are still some seats available, so last chance, so to speak. We will do that on Monday and Tuesday, and I think it will be quite nice. It will be quite a cool workshop. And with that, that's all I have to say initially. So, Flo, what do we have as a topic for today?
Today we have a wonderful new framework as a topic called Picard, which is the new cutting-edge technology to create Micro Frontends.
Awesome. So I think this is this guy here. So this is Picard, right? Who doesn't know him? This is the captain of the new next generation spaceship Enterprise of the Federation of Planets. So who's familiar with Star Trek knows, of course, who Captain Picard is. But now, of course, even the persons who don't know Star Trek get familiar with Picard, because Picard can be now the captain for your next generation of Micro Frontends. And what we'll do with the time today is just briefly go over it and see what Picard can do for you, and also look at the current state of implementation there, and what's about to come, and all these things. Sounds good?
Sounds awesome. If anybody knows this framework already, type it in the chat.
Alrighty. Cool. And also just place your questions in the chat and we will take them just whenever they come in, right? Because we are here not in any formal session, but this is rather, right, really dynamic. All right, cool. So this is the page. It's Picard.js.org. On this page, you will get all kinds of information about what Picard currently can offer, of course. Plus, you can get all the links, for instance, to a Discord. This is the same Discord that you can also use, for instance, today to ask questions. There we have a sub-channel for the Micro Frontends Meetup. And then most importantly, we have links to GitHub to find the source code as well as NPM and JSR as registries, right? So following the link to GitHub, you will end up at the repository that you see here. So this is Picard. If you don't care about the source code, of course, you will not have a look there. Potentially, it might be good also to check out issues or, of course, post your own feature request, bug, whatever. But the getting started, etc., that's much better explained on the website, right? So there you will find all kinds of information, what it is and how to use it. Now, how to use it is maybe where we should get started with Picard, because what do you need to, let's say, start using it? Well, you don't need much. I will not go over all the essential examples because we went over them in my talk at the Micro Frontends conference. But just to give an intro for those who missed the talk, you can just use Picard on, let's say, any static website or any HTML, so to speak, only by introducing one script, and that's all you need, right? So once you have this script, then this opens the door to using things like these web components. So you see the Py component with name column here, or the other one, same name, but different source now, right? And you also see, of course, a Py component counter here. Again, different source. And there are other attributes like this format. All right. So that being said, that's the basis of Picard. So you can just drop it into existing.
My audio quality is bad. Is it better now? Can you write it me in the chat? But anyways, sorry for interrupting.
Now it seemed to be good. Yeah, let's wait for a chat. There's a little bit of delay always, but let us know if now the audio quality is much better. And I think
okay, it's better. Yeah, thank you.
All right, whatever you did well. It's always good to start with a bad audio quality and then to improve it, and everything's, well, this guy's magic.
Get all the blips out of the way, right? So, yeah. Now you can see, guys, this is live. This is not a recording.
Awesome. Anyway, so that's, let's say, the brief intro to Picard. You can just use it. You have whatever, let's say, source you have, can be PHP generated website or so. You can just drop it in and you're good. And that solves essentially the story for client-side rendered micro frontends. But Picard can do a little bit more, and this is the other aspect we can have a look at. For this, let me briefly show an example here. And I'm not sure. Let's see if it works. 8091. So let's try going there, and it should be a tractor example. If it loads, looks good. So let's see, it seems to be functional. So I can just click around, put a few of these tractors in my shopping cart. I mean, why not? And that's it. So that's the famous tractor version 1 example from Michael Gers. But you've seen already, that's SSR, so that's server-side rendered, which means I put in here, let's say, settings. And this might be a little bit small, but I just now do this once to disable the JavaScript. Now the page reloads, but what you should see, if I click around, I mean, it's the same behavior, right? So everything is server-side rendered, and there is no client-side JavaScript here, which means if I press, I increment the button, right? So the card. And JavaScript is not used at all here. Still, if we would look at the source that's delivered, maybe let's do that for a second. and I will make it therefore a little bit larger here. So bear with me. You will still see, hopefully, I'll make it a little bit larger as well, that these Pi components that we've seen initially are still present, right? So we got a web component in here, but if you know a little bit about web component, they usually just render, of course, on the client, right?
Yeah,
so
how is this done with the server-side rendering? Super interesting.
Yeah, this is a great question. So this is all done by Picard. So Picard looks at the HTML that's streamed through, and if Picard sees certain elements, let's say, for instance, a Pi component, it will try to expand that by, the component that was registered from a certain micro frontend. So here, of course, it matches this to a micro frontend that was known to Picard as blue. And using the information that Picard has, it finds a component, hopefully, and it places all the, let's say, content from this micro frontend in the inner part of that web component. So essentially, when streaming out, Picard is doing a little bit of magic and looking at the code and, of course, expanding that, getting some knowledge about the solution that you have. And this way, Picard can, of course, also operate on the server. Now, you need, of course, to integrate it some way. So here I've made, in the simple example, a little Express.js application. So this is just plain Express.js, right? And I'm using a certain package called Picard.js Node. So we have a variant of Picard.js that is tailored for Node.js. And this one exports one function that is called initialize Picard. And I need to do that whenever, let's say, I want to interact with Picard. So I need to have Picard initialized. And in this function, I just need to tell it, now, for instance, what feed to be used. That could be a certain string that goes to a Micro Frontend discovery service. Or in this case, we are just using a plain callback. And this one returns a promise. And it can be any format that Picard supports. So, for instance, this is the so-called native Federation manifest format, which is just a string-to-string dictionary, right, which maps names of microfrontends, like Blue, for instance, to their manifests, which is a JSON file.
But I have a question before we dive deeper. So, because you showed us now how to work with the server-side rendering, and I also can see under services there's framework React. How many frameworks are supported by Picard then?
Out of the box, essentially none, right? So there is a generic component model, and you can just follow that in your micro frontends, and it will just work. Otherwise, what it also supports is if you already are using single spar to, let's say, generalize whatever framework you're using, right? So single spar can be thought of as a kind of universal component format, right? So if you're already using single spar, then this one is also supported. But otherwise, you need to teach Picard about your thing. So here we have been using React, and I haven't even shown the micro frontends yet. We can look at them in a second. But I've used React to, let's say, export my components. So out of the box, this component wouldn't be usable by Picard, right? It doesn't understand React. It has no idea of React. It doesn't have React installed or anything similar, right? Therefore, you will need to teach it, and the easiest way to do that is just to bring in another service. And framework-specific services are always in the namespace framework, so it's framework dot, and then you just give it the name that you want to denote your components with. So if you would look at the layout here, so this is just the initial HTML that we are streaming through, right, and that will expand into more and more. You can see we are using a Pi component. And in here, we are specifying framework React. So we are already telling Picard, by the way, so we want you to render a component called products of the red micro frontend. And by the way, this component is following React.
So this is how the framework knows that it should look then to the converter that we just saw configured in the
exactly, and that's how it goes to that converter. The converter, if you look at it, is not so complicated from the code perspective, because here it really doesn't need to do much. So essentially, this is a service in Picard, which means it's just an object with a certain API. The only API that this converter service has is a convert, where the component is thrown in, right? And what you need to return from there is just a generic component model. which usually consists of a lot of things that we here don't use because we are not on the client side, for instance, so we don't need to specify those things. But since you want to render on the server side, you need to specify the stringify function, right? And all we do in here is we call the render to string from React DOM/server and pass it on our component, and that's it. So Picard does the rest, right? So Picard then can pick it up, can call stringify under the hood, and yeah, we never know that we used React. They don't know. You could use anything, right? So this is also a way how you can mix different frameworks together. You don't care. Ideally, you also don't need to specify for your components what framework they're using. But here we are doing a more strongly coupled approach, meaning that we are really referring to the components directly via PyComponent. So here we need to tell Picard, of course, how these components look like, where they come from, and how to, let's say, treat them. And we do that via the framework and the other attributes here.
Yes, yeah, still makes looks like very little effort for making different frameworks work together in a server-side rendered context.
Yeah, so the magic then realizing those converters, and they can be as simple as the one shown there. Certainly, some converters might need more attention, and but in general, I mean, we aim for a solution where you can potentially use existing converters. That's why single SPA is support out of the box. So they have already a ton of converters, right? And you just use single SPA, and then you just give as a framework single minus SPA, and there you go. It will just work out of the box with this model. But you can also keep it a more, let's say, direct approach, what we see here, and you just specify it on your own. There was also an idea that we want to support the converters in the Astro ecosystem. So who knows Astro.js? So this is also quite a nice project, and we were thinking about it. At the end, at least for the moment, there are a few, let's say, blockers here to use them. Maybe we will pick it up in the future again, but for now, we are quite happy with single SPA, as it's also a very prominent solution, of course, in the Micro Frontend space anyway. So yeah, supporting it was important, I guess. Alrighty, so once we initialized Picard and told it a little bit about what we want to support, for instance, extra services and things like that, or where our initial set of Micro Frontends comes from, it's time to actually create our Express.js server, right? So we do all kinds of things that we usually do in Express.js, like specifying, I don't know, static files that we are taking here from a public directory, or defining some redirects or other route handlers. And specifically, two route handlers are here important. So one is for all the products. So if you go to product / I don't know, Porsche or Fendt, then we want to handle that. And we do that here, right? And the other is, of course, when we get a post back because someone puts something in the cart, we do that in the app.post down there. Now, going into the actual, let's say, creation of an HTML view, that's done on the get request or get endpoint defined here. We call this layout function that we defined. You've seen it. It's just more or less a template string, right? And plain HTML. So really not much, but we put in some data that we then escape and place in the data attribute. So far so good. That sounds all right, I would say. But that's just that is content that wouldn't really be usable. I mean, what we could do, just as an example, is to give back this content directly, right? So not to call the next line, but just let's see how that looks like. So I will just build and start again, just to get a little bit of feeling what's happening. And let's see, hopefully it still works. I mean, working is relative here because at the end of the day, I mean, I think this works. This warning doesn't come really from the thing. It works, but what you can see now is that essentially we got a very strange output here. We got a Py part suddenly in here. I will come in a second what that is. And then we have a Py component, but that Py component is, of course, empty, right? So essentially we just passed on this HTML that we've seen to the outside. And we didn't go through Picard. Now, if you would have Picard on the client here, I mean, this could still render and do something. But as it is now, nothing will happen. I mean, we didn't do anything. We don't have any JavaScript in this solution here, and the server didn't do anything with Micro Frontends. So what's the solution here? The solution is to just say, hey, before I send out the content, let Picard go over it, right? And essentially stream that through Picard. That's done via the decorate function, and that takes the content and looks at it and gives us a resulting HTML. So essentially, it's the initial HTML, but augmented in the sense that, for instance, such PyParts things, they are replaced with real parts. So, like for instance, a script part could be replaced with some JavaScript to actually make that, let's say, hydrate on the client. And the style part could be replaced with all the style sheets that have been aggregated from the different micro frontends that are used to compose the current view, right? And especially the Py component and these parts, they are replaced by whatever is the component behind it, right? So if we do that, suddenly, let's see, does it stay empty? Did I make a mistake? Maybe I made a mistake. Oh, I didn't save. So I made a mistake. Should save before I run the build. And now should look better. That looks better again.
There it is.
And there it is. So no PyPart here. That was already fully resolved. And I mean, I didn't drill into that beforehand. But we now have, of course, these style sheets and additional styles being linked here, right? And this is all up from the PyPart of the style. And of course, our component was expanded, and that inside had more component references that were also expanded, and everything done by Picard. So Picard took care of that. And that's great, right? So Picard, just with a single command here, can render all this stuff.
Can you maybe tell us in this part how Picard works and orchestrates the micro frontends together? Because this seems like very interesting now.
Yeah, so what Picard is doing, I mean, first, of course, it has kind of its own kind of queuing system. And when you await this, it first makes sure that all the necessary things have been processed. So for instance, when you start Picard on the server, the feed, if given, will be grabbed, right? So we will already resolve this. And this is not, let's say, alone, because we have micro frontends in here that depend on this JSON. So we will have subsequent requests inside. And so all the information about these micro frontends that have been found already from this discovery feed will need to be resolved, right? So we will drill into the red, the blue, and the green remote JSON specifications and load then respective modules and whatnot. So everything is loaded. Now, with this, we form, of course, some kind of an information graph, and we know now what micro frontends exist, what components and assets they have. And once you go over the decorate function, what it does, it scans your HTML code, and when it finds something like Py component, it looks then for the specific source, right? If the source is given, it will grab all the info about it, and then it checks out if it can find a component with the name that you specified. Like we specified here a name called products, for instance. Then it knows in the native federation word this is meant as /products, must be an exposes key. And so it looks in the information of the red micro frontend, and it will find, here we placed it, MFs. Here's all the output. And it will find, there is one key in there, and this key is /products, of course, as expected. And it must be resolved with the module found in here. So this products JS. So it will resolve this, of course, and it will load this module, right? Now, this is, of course, all the part of the loading, right? And now follows the part of really then mounting, etc. So the next part is it will be handed over to the respective lifecycle service inside of Picard. and Picard will then look up, hey, was a framework specified? If yes, use that. Otherwise, what's the default framework here, etc., etc. It tries to match things, and at the end of the day, once it has a valid lifecycle, it's returned to the web component. On the server, we don't have a full web component, so it's returned to so-called virtual web component, and this one would just look up for the stringify function and stringifies the content there. So
and,
that's
sorry. All your examples were showing native federation until this point. Are other formats also supported?
Yeah, so the example that I've taken here is having native federation. We can drill into that in a second. In general, we support module federation at the moment, native federation, and the pilots version 2. So pilots can have different specifications. There is a very old V0. We will not support this. There's a V1. We will potentially support V1, but not sure yet about it. And there's then the state-of-the-art V2, which is also was the format when Pyro 1.0 was formed. So pilots in this 1.0 format, in this version 2 format, so for Pyro 1.0 and higher, are certainly at the moment by default supported as well. In general, you could also throw in just a system.js or ESM or whatnot, but and we will potentially specify the format that you can give it a name, the format, and that we will know about it. But at the moment, as said, module federation, native federation, and pilots version 2.
So I can orchestrate micro frontends from different formats with different frameworks and put them all together. So the next question that immediately comes to my mind is the question about our beloved dependencies in our JavaScript ecosystem. So how are dependencies handled across different formats of federation and frameworks?
Let's look at an example to see this in action. So here I have a very simple website, and it has 6 micro frontends on it. They are rendering just below. Each has a component in there, and we're just rendering this one component that each micro frontend exports on this page. All right, so 6 micro frontends, each one printing hello from whatever name, and then showing some emoji. Now, all of them are using one and the same dependency called emojis list. I mean, we could also just hardwire the emoji in there, but that would defeat the purpose of this demo. Some of them even then share something else, like fireworks, and some just bring something in, but no one else is interested in that. So the fireworks looks like this. Can turn it off as well. Here, also fireworks. It just works, right? Yeah, fireworks just works. And then here we can make a request with a library called Kiwi, it also just works. Now, this is all client-side because dependency sharing makes most sense on the client, of course, because there we want to get the performance benefits of sharing the library. And if we would look at the, let's say, request history, we would see, of course, we load things like RPK or Picard debug, things like for our ecosystem here. But we also get in all the microphones like remote entry MJS, remote entry JS, remote entry JSON, index meter JSON, MF manifest JSON. So these are the entry points of our 6 microphones. So we have Module Federation version 1, we have Module Federation version, what I would call 1.5 or something, with a module-based syntax. We have Module Federation version 2 on Manifest. We have 2 native federation modules, and we have a pilot, of course, in version 2. So all kinds of things. You would not have this kind of mixture later on, but for us, this is both a showcase and just a good basis for end-to-end test of Picard.js, right? So that we can make sure that this thing is working as it should. Anyway, so once we loaded, of course, these, let's say, manifests or entry points, we can load the respective components, and we will, of course, need to load the emojis or the dependencies in general. And what we can see here, right? I mean, here we can't see much, but this is really a module of a micro frontend. But if we look at 8.25, you see all these emojis in there. I mean, these are strange names here. And you, I guess, need to trust me. I mean, we could go over all these scripts, but you will not find emojis again somewhere else. So here, this is fireworks that you can see with all these mouse and all these things, right? But then again, this test 6, this is definitely module federation. This is some chunk. This is also native federation one, right? Another native federation one. This is key Y, but exported now from native federation. So long story short, you can share all these dependencies, and Picard will help you do that. And if we look at the code, it's the same code essentially as the entry level example that you can just place your Picard script somewhere and it works. Because here I'm not telling Picard anything that these micro frontends might have some dependencies, right? That's all just distributed sharing as you know it, featured by module federation, native federation, pilots, you name it. And if we would look now in, let's say, one of these things, so here we got the micro frontends all in the same repository. Let's use native federation. Well, all it does is it includes emojis list and key Y in its dependencies list. There's no customization in the Vite config, besides, of course, your standard native federation stuff. And it will just work. So the output here has the 2 packages in the shared segment, and that's all. And Picard just does the right thing, right? It loads this if it's not available, and otherwise you can reuse what you already have. And the same, of course, applies to, let's say, module federation. So here we see module federation version 1 used with RSpec, and what you can observe that we share emojis list, we share fireworks, and it just works again, right? There's no customization done here regarding Picard or regarding any of the other microphones that you don't know about. So this thing just works, and it works across these boundaries very nicely, so you don't need to.
And all dependencies just shared one, conglomerated beautifully.
Exactly.
This sounds very powerful, yeah.
So this is what it can do for you. And regarding dependency sharing, of course, it can do a little bit more, because you see here already, I mean, I'm on localhost, which is why you get integrated this Picard.js. So this is lazily loaded only when you're on localhost and only if you could use it. And what it does is it opens, let's say, a channel for tooling. So here, this is a browser extension called the Piral Inspector. So it doesn't have any idea about Picard, but Picard, of course, did know that such a tooling exists. And so this Picard debug opens this channel, and now the 2 things can communicate. So the browser extension can be running in Chrome, here in Firefox, etc., can now communicate to our website via this Picard debug MJS. And the powerful thing about it is it can not only visualize these things, right? So we now see what microphones are in there. So these are the components, etc. But we can also go in and see all the dependencies. So here we see exactly what was loaded by which micro frontend, and this is quite nice, right? So you can drill in there and see, oh, this is my native federation 1. And by the way, it depends on key Y in 140 or higher. And this is another native federation one. It only depends on emojis list version 3.0. So quite nice that the tooling just works, and you don't need to do anything, because Picard does everything for you, orchestrates that, allows you to just use the dependencies as you like to across different formats if you want to. And yeah, so our plan also with this is that the Piral Inspector will, let's say, not get, let's say, a complete overhaul, because as you can see, it already just works. But maybe some of the wording that you can see here will maybe change with a future version, that either it's always called just micro frontends instead of pilots, or that the wording can also be determined by the counterparty in the debug protocol, so that the Picard debug MJS can just dictate, oh, you need to call it now micro frontends instead of pilots or something like this. So here we don't know, but rest assured, it could be that more information will soon to be displayed in the Piral Inspector, which is empowered.
Because you are the author of both Piral and Picard, right? So right. Could you say that Picard is the successor of Piral, or what is the correlation or the idea behind these 2 products?
In some sense, you could say that, but I would never, let's say, have a public statement regarding Picard as the successor of Piral, because even though there is some truth to it, in general, that's not true. Picard is a library, and it is meant as a library, so you can just use it in certain scenarios. So for instance, if you have multiple formats, or if you have this one scenario where you have a team, they have, I don't know, use PHP, and they also want to display your micro frontend that's powered by Module Federation, they can just use Picard for that. So these are the scenarios where, of course, Picard makes sense today. So it's like a drop-in thing. But Picard, of course, makes also sense if you just want to have loosely coupled micro frontends. So you're already using Module Federation, keep on using it. And all you do is, instead of having your imports everywhere and then having to do error handling and everything, you can just use PyComponent and you're good. You're already loosely coupled, and you can also power your application like this. So Picard is really a library, and it's meant like this, whereas Pyrrel is a real framework. So it has a CLI. It doesn't require it, but let's be honest here. You will want to use it, so let's say it's required. Picard will never require CLI or something, right? It will not tell you how you need to structure your application. It's just a library that you drop in, whereas Pyrrel really makes a lot of decisions for you. Of course, almost all decisions you can change, but still it's an opinionated framework, and it will remain like that. And the only thing now what we can say, why could we call it a successor, is Picard will replace a part of Pyrrel, which we currently refer to as Pyrrel base. So it's a base library, let's say. Picard will actually be the replacement of that, going into Pyrrel version 2. And this, of course, will change a little bit how Pyrrel works internally. And as a benefit or outcome with Pyrrel version 2, you can have a lot more flexibility, because now it stands on the shoulders of Picard, right? So it's much more powerful already, and it allows you to build much more framework and tooling agnostic app shells and microfrontends in general. But Pyrrel itself will remain a framework, and therefore will remain its own thing. They will continue to evolve then side by side. So it's if you want to have an official statement, it's not a successor. It's an extension of the ecosystem, and it makes it possible for everyone else to just build outstanding solutions that are performant, really flexible, using micro frontends.
So when I put the little Picard script into my static website, then I have the Pyrrel base, so to say. Reference.
Just much better as beforehand, because beforehand, I mean, this is the reason why we started developing Picard. Pyrrel base was meant for this use case, to be honest, but it never fulfilled this use case. So you needed at least some tooling to get started with it, so a bundler or something, right? You couldn't just throw it into some HTML, as we can see here. And it also then didn't provide anything regarding a component model, for instance. So it was really naked. It just had an eventing system and dependency, let's say, orchestration mechanism in there. But that's it. So there's nothing else. So meaning that if you want to build a real-world micro-frontend solution on Pyrrel base, you needed to, let's say, do a lot more steps. And usually, I mean, you expect when you get a library to do these steps for you. And that's where Picard was born. So this is how Picard comes in, because it fills out this slot, right, so to speak. It just covers it. And you now have this library that can do all these things for you if you wanted to.
Very cool.
All right. Okay, so we're already a couple of minutes in. But maybe before we continue, let's conclude the native tractor that we've seen beforehand. So dependency sharing, check, right? So quite cool. Can do all that. Now, what we didn't look into beforehand is how these microphones looked like. We've seen the application shell, which is here just our server that starts. So there's really not really an application shell, because all we do is sending out some HTML and having a Py component in there that triggers everything. But the question, of course, was, how do the microphones look like? So here, for instance, we have the red one. And if you look at it, it's really simple, right? So, I mean, there's not much in there. There's just a JSX file, which defines some data, because I want to show something. And then we're having the product page in here. That's it. All the product page has is a link. So this is the style sheet that we want to transport, and actually getting the path via the import meter URL. So quite nice in my opinion. You're just using ESM standards, and we are exporting the default as the component, and that's it. The rest we do here in this build system, which doesn't do much. It just, looks at the product.jsx and produces this in a dist file, and that's it. So all this thing does is it uses the entry name, which you provide in a build script. So build red just places in the places in the red products JSX, and that's it. And we do the same, of course, for something like blue. Here we have two components actually, the basket and the buy button, but they both look the same. So these micro frontends, they are intentionally really kept simple, much simpler, of course, than you would potentially have. But it's not the point about, let's say, the complexity of the source code of the micro frontends. The point here is always, of course, as it is with Picard, about the orchestration, right? So Picard will never tell you how you should build your micro frontends. It will only tell you if you want to, let's say, use different things together, you can use me because I orchestrate things. And that's all it does. All right. So this is how a micro frontend looks like. Again, in the end, that is just a process of, in this case, ES build, forming a valid ES module, right? So we see those here in the MFs folder. And so something like basket info.js, this is really just a valid ES module. And that's what we can now consume, of course, in the browser. But what we do here is we consume it on the server, which is quite nice. So we didn't even need to think about it, right? And we just, use it on the server. And even with markers, and I mean, this is maybe underappreciated, but when this component is evaluated on the server needs to know what React is. And I mean, how should it know it, right? I mean, we don't, here our server has React in there, so here our server could know it. But here could be anything that we specified, of course, in our import map, right? So we're actually using React for this, in this case, from ESM.sh, so from some website, which is kind of crazy, right? So we are not really sharing React on the server. So React is also used in a distributed sharing mode amongst these micro frontends. So they evaluate it on the server, which is quite important because, I mean, the micro frontends might come with all kinds of dependencies, again, that your server doesn't have, of course, installed. And so why should it, right? This is what the micro frontends need to know about and need to use accordingly. Anyway, so it respects this, and of course, as you can see from the rendering, that just works at the end of the day. You can build even larger things with this. So let's use this one as an example, and we don't have so much more time, but maybe we could start with it and also make this, let's say, a server-side version. So what we have here is the Traktor version 2. So after version 1, there's a version 2, as you all know. And in this case, is it already there? Yeah. In this case, it's the Traktor of Michael Gers again. And let me don't display this for the moment. And this is how it looks like, right? So it's a little bit nicer than the initial version. It also has some routing, as you can see, demanding. And I can now add this one to the basket. It only comes in polar white, but maybe I find, let me look around, maybe autonomous machines. Oh, this, yeah, exactly right. This is what we should grab. So here we have now in our basket these two things. I can go to checkout, can enter my name. So once I pick the store, I can place the order, and then tada, we get confetti, and we are done. So this is the whole demo. It has a couple more screens, of course, than the original. So actually a lot of screens. And you can implement it in multiple ways. And what we did here, just to go briefly over it, is we created some static HTML. We put in, of course, all the nice resources that were already provided by Michael. So he already had all the different icons, etc. So you got the nice favicon and everything. And then at the end of the day, once we, of course, set up a little bit of a global styling, so just a font face and some general rules, we include Picard.js. And what we do is we abuse the fact that Picard can also be a client-side router. So all we need to have is a so-called PySlot component that can have a name, but if we don't use it with a name, we can use it with a special kind of a relation attribute, so the rel attribute, and we give it a relation of router. So with this, Picard will essentially say, okay, let's look for a page, for a component called page : / because we are currently on the path /. And if that's registered, we'll load it. And we can actually see that also on the client side already. So if let me restart here. Let me also refresh that we have everything clean. And we get a little object here on window, which is called Picard. Actually, at the moment, I'm not sure if this is fully documented because we don't know yet if we keep that and etc. But you can potentially, we will keep it because it does seem unique enough that, yeah, we can do it. And what you can do here, you can read the state. That's the state that Picard currently knows of, right? So here we see, for instance, what CSS assets are known by it. So it knows 3 assets, right? You can see what the origin Micro Frontends are and what the URLs to this are and what IDs Picard gave them. So nice. There are no other assets. There could be like WASM and whatnot, right? So any kind of asset that you, let's say, want to have managed by Picard, you could throw in there. And we, of course, we have our components. There you can see we have a lot of, let's say, quite, let's call them cleanly or clearly readable names like add to cart, footer, header, mini cart, recommendation, store picker. Quite nice, right? But then we suddenly have a whole class of components that always starts with page : So we have, for instance, page : checkout, blah, blah, page : checkout, blah, blah, etc., etc., page : /stores, but most importantly, also page : /. And page : / has one object with the ID drx_c5. And if you now look at your body, what happened is Picard, of course, was doing its job. It was filling out the name attribute here, right? Because it's a relation router, so it keeps it in sync. And more importantly, it placed in a Py component, and you can see here, there's a new component ID, the XR_C5. So Picard looked it up and placed the right thing in here, right? And Picard will do this job also in the future. So if we now change, so what have we done? What do we have also? We have, for instance, the /stores, right? This might be a good example. So let's see if that works. I just go to /stores and Picard does for me the rest, right? So all I did is I changed an attribute in HTML and then Picard kicks in and says, oh, okay, I need to keep this in sync, by the way. So let's look it up. And for this, we got one component to render, and that's called the VHMRTK, whatever. And it does that, and the whole page changed very nicely, as it should, right? So it keeps this in sync. So usually you don't want to change the attributes, at least of a rel router slot, because, I mean, this is the responsibility of Picard, right? So whenever the route changes in the navigation bar, Picard changes the name, and since the slot changed, it reflects it on its contents. And the contents is a Py component, and that again has contents, and that's how we roll at the end of the day. So far, so good. So this is how this example was, let's say, grafted. So it looks quite easy. The Micro Frontends all there. They are again written using native federation. And there's, of course, one reason for choosing native federation. We don't need essentially any tooling. I mean, yeah, a little bit of tooling could be good because that allows us, in this case, to write preact. So all these things are using preact here. But I mean, we could potentially even throw in the original ECMAScript modules, right? We wouldn't need a tooling if we wouldn't want to use something like JSX, for instance. And that way, I mean, we can stay really independent of any tooling, which makes it for the examples quite nice because, you don't need to install so much and you reach maybe a broader audience. So this is why native federation was picked here, but we could have chosen any other technology here as well. right. Maybe the only thing to take care of is we still have these, let's say, definition files. So if we look at, for instance, let's pick of Explore, the remote entry JSON of this file was in this case written by hand. So you can, of course, grab some tooling for data federation, then it will generate this file. This is what was done, I think, here earlier. But here, this file was just written by hand. And the advantage here was also that we can specify now these key values as they should be, right? To specify now correctly these page identifiers, for instance. So for instance, the category, you can see this is a dynamic match, right? So products category, this is a dynamic match, but still the router in Picard makes this possible. And other than that, I mean, this code here is straightforward as you wanted to. It was just, let's say, copied from the blueprint that Micro.js provided. And that's all we needed here to have this fully working. And what we could do, of course, now, but we don't have enough time, but what will definitely happen in the future is that we take this code and we, of course, make it render also on the server. Because after all, out of the box, it should work in quotes, except, of course, some parts that at the moment rely on that, I don't know, there's a click event and then just an event sent. Here, of course, there should be then, let's say, a fallback or another mode where we post to the server, right? So things in the code base of the Micro Frontends would still need to be extended to make sense in a server, but the end result should be that this thing also renders without JavaScript only on the server, and it would work. And that's the basic idea here, right? Of the tractor store example, that you can have this thing. It's a lot closer to the real world than the original V1 because there's multiple pages. It also has more dependencies, so there's not only Preact in here, but we also have the confetti. And what you can see already, let's do this maybe really quickly. So we load a lot of things here, but what we didn't load was confetti. So there's no confetti, right? So, and what I can show you, let's maybe keep confetti conf in here, so we should see it, I guess. We can just browse, pick a tractor, right? Check out, enter name, select, place the order, and now you see something was loaded here. So we now loaded the confetti from our remote source. I didn't even install this dependency locally. That's how great this is that I didn't use any tooling, right? I mean, I used a little bit of tooling, but if you look at, I think this is the checkout, the confetti is really just coming from here, right? And I mean, I didn't even there's no package JSON here anywhere, right? I didn't even install it. I just built this thing. I refer, of course, to the confetti somewhere. Where is it? On the thanks page. And that's it. That's all I did. It's that simple. Yeah. So that's again why why ES build and why native federation for this example or for many examples in the repository. But also because, of course, it makes sense, in my opinion, to use browser native capabilities like ESMs and all that. And Picard just makes it quite easy to utilize those, in my opinion, right? So again, we're using here remote source, which is giving us some ESM. We're bringing it in on demand when we are lazy loading the page, and that's it, right? So we did also lazy load this page only when we needed it, and then we loaded, of course, the dependency, and voila, there's confetti, and everyone's happy, right? So this is how that works, and this is how Picard, let's say, works in a nutshell.
And when we are here already at the very end of our talk here, a question that I would have is now, how far is Picard from being able to be used in production, or what features are still missing?
Yeah. I think most parts of it are ready. They could be used. Honestly, we are also already using it in some smaller things. But what we want to achieve is having a 1.0, which means production readiness by end of August. And for achieving that, we want to be feature complete in July. So most things that are still missing are, let's say, a lot of quality of life improvements, better documentation, of course, all these things, and that will progress. Documentation, of course, never stops. You can always also improve there. And we just started, of course, since the conference a month ago, we started ramping up the code on GitHub, ramping up more examples, etc., having the test code base there solid. And I think this is now in a good stage. So now we can add more and more features to reach the point that we anticipated beforehand. And again, this will most likely happen in July. Any feedback, of course, appreciated until then. We really want it. So just because it's not usable for production doesn't mean don't use it, because we need, of course, this is always the chicken egg problem, right? So we need, of course, someone to use it or to find out what is still missing. And that's the only way to go forward. And of course, we have our own agenda, and we want to let's say, streamline this and make this as solid as possible. And once, according to the issues we see, the feedback from the community, we say it's a 1.0, and that will happen quite soon.
But then make sure to everybody check out our GitHub regarding Picard.js. Check the website. And also don't forget to join our Discord server, where you can always ask us questions about the product, or if you find any bugs, you can already join there. Florian is very active there and will help you guys work out Picard in no time.
Yeah. And I mean, on the website, as initially said, you find the link to the GitHub. On GitHub repository, you have all these, let's say, inline examples. Let's call it like them, inline, because they're usually smaller than, they're not real world scale, but we will also have real world scale examples, just not in this repository, but in other repositories in the same GitHub organization. And the tractor example that you've just seen, as well as all other examples, they all live in the examples directory of this repository that you enter. For the tractor examples, we also have a little bit of, let's say, documentation in there, so you can read a little bit about it. And it even shows you performance-wise where you end up with here, right? So this is, for instance, one of the points. Until a 1.0 we want to improve. Here it should be possible to have a 100% performance line. The reason why I know that it's possible is because Pyral already achieves it in the tractor version 2. So if Pyral can do it, and Pyral is arguably larger, then this thing can do it here as well. And this is one of the goals that we have. To make this, for instance, for the 1.0 really top notch. But then again, I mean, this is all a single page application, meaning that if you don't get 100%, I mean, maybe you didn't want to have it, because if the best possible performance is what you strive for, maybe you want to go for the hybrid concept where it's rendering on the server initially and then the client takes over. And again, this is also possible with Picard, and in my opinion, much easier possible than, for instance, what Pyral at least delivers today. Pyral version 2 is a different story here. But again, all these examples will follow. Also, how to do the tractor with server side and in hydration mode. So keep an eye on this repository. There will be a lot more changes. And again, play around with it. If something is not working, create an issue. We'll look into that and we'll try to improve the product there. Then, hopefully, end of August, we have a 1.0.
Very, very nice. Yeah, it seems very powerful just to drop in a script into a static website and enable micro frontends for different frameworks, different formats of federation. It's very cool.
Awesome. All right. With this, we are, I think, already at the end of the hour. There are no more comments from the chat, I would say. Let's call it a day.
Let's call it a day. Thank you, guys, for everyone that came to our stream and stick with us. We hope you all enjoyed the talk very much. Make sure to check Picard out, join the Discord, and see you guys next time for the Micro Frontend Meetup.
See you, everyone.